We have a lot of ideas. I do think we're close, but it's a challenge.
I haven't opened. I have not done anything because no, it's okay. I'm happy to talk about it if you want me to talk about it.
It just, I mean, I would just mention the changes will be, once you are satisfied, yeah, we will double check.
That's fine. You want to, yeah.
I mean, if you want to say, just set up.
Well, I mean, it's ties into the 3475 stuff, so kind of talk about it there.
One more minute?
This is all we have. This is like usually.
I think the TCP Google people are not there. John's coming, right? Are you aware of the TCP?
Yes. And they actually, the original implementation was rate-based. I think it's time for real-based implementation.
Okay.
Yeah.
I think we start, right?
Yeah, definitely.
No, we couldn't start before the note taker.
Oh.
Well, we waited for you.
That's why I
We both are talking. That's why. Yeah, we can move it. Yeah.
No, that'll work fine. Hey, Bob.
Sorry, guys. Just uploaded the new slides. Did you drop them?
New slides.
Oh, new slides.
Sure. He provided new slides. Oh.
Oh. Okay, so they're not
to me.
included in the data tracker yet. Okay.
Thank you for noting.
I would not have checked that.
I loaded up in the data tracker. Pardon?
Do you have a QR code for?
I have no idea.
I mean, it's usually on the, like the default screen.
Oh. Yeah, I can stop presenting.
Oh, is it showing up then there?
I will stop. There you go.
Thank you.
You're welcome. It is also at the entrance.
Windows 10 and 10 each, you should probably make sure that Windows is not confusing.
It also is at the door, but yes. If folks could sit down and also make sure to register your attendance, either scan the QR code here or at the door, or log in. All those things seem to work well.
So I think now you have to resync.
Yeah, I think it just shows up in a moment, doesn't it? Like, I think if I wait like 3 minutes, it'll just be there. But I can start with the chair slides now.
Yeah. Hello, everybody. This is TCPM. We have 3 co-chairs. My name is Michael Tüxen.
Oh, my name is Ian Sweat.
And Yoshi is remote. Okay, so next slide. This is the note well. You should have seen it. Next slide.
The session is being recorded.
The session is being recorded. This is an important information. Richard was so nice to act as a note taker. Yoshi is doing a JavaScript, and if you're submitting in the future a document where you think TCPM should be interested in, please put TCPM in the name of the document so it shows up in our view in the data tracker. Next slide. So this is the agenda. We will provide an overview about the working group status. We have one presentation for working group documents. Basically, it's an current status and overview about the document being considered for going into working group last call next. And then we have a couple of other items. One is future status of RFC 3465, which is ABC. We have TCP egg rate request, which we have seen a couple of presentations already. A new one, TCP service affinity option. Yoshi is talking about a new document describing the differences between standard congestion controls, and if time permits, I wanted to talk about whether 120 seconds is still the correct value for MSL and TCP time wait. Agenda bashing. Anyone wants to change anything here?
Martin Duke, just I've been using this slot in working groups to show for the congestion control working group side meeting at 5 p.m. on Thursday. That's tomorrow. We will be bashing the proposed charter. The TSV, or actually this list has an announcement with like links and so on if people are interested. Thanks.
Yeah, thank you. So I think we go with this agenda. Next slide. So these are the documents. We have finished since the last IETF the TCP base spec. It's now RFC 9293. Thanks to Wes for doing this work. We have the Yang document and the RFC editor queue. It's there. It's done, but it's in a misref state. We have HiStart++. After the working group last call, the AD had some issues, editorial questions, and one question regarding how to handle the L value mentioned there. And there was a new revision submitted yesterday, I think, which basically says use L equals 8. If you're not pacing, use L equals infinity. If you are pacing with mandatory language. And the process is that this is discussed between the AD and the authors, and once it's finished, it comes back to the working group for a short working group last call about this change.
Yes, there's normative stuff, so it does matter. I think the agenda item I have about 3465 will make it clear what the substantive issue is, so we'll just hunt for that.
Yep. The next one is Cubic, and Yoshi is the document shepherd. So Yoshi will give you an update on that document.
Cubic, we already submitted ISG, and then right now the status is device ID needed. So I think we are waiting for the new revised version of the status.
The next document is PRR, which is in working group last call, and Yoshi is also the document shepherd for that.
So this is right now working group last call, and we got some comments, and then I see some users responding. So so if you have any more feedback, please send to the mailing list as soon as possible.
Yeah, so we will close the working group last call soon, but if you have any issues, bring them up now. The next three documents, which are in our list of milestones, is Accurate ECN, which is the document we want to last call next. After that, Generalized ECN, I think we decided that I'll be the document shepherd on Accurate ECN, and Ian is the Generalized ECN document shepherd. And then we have TCP EDO. I recently updated the milestones after discussion with Martin, and moved milestones being in the past to a realistic thing. I moved it to December 2023, but we recently got an email from Joe that he thinks TCP EDO is ready for working group last call, and he also has another document about extending the SYN segment, which is right now not a milestone. So for the second one, the chairs are still discussing whether how to handle this. Does the working group have any feedback on TCP EDO being last called soon?
A specific question I wanted to ask was whether there was implementation experience of any sort, and if not, how does the working group feel about standardizing something that has none?
So the current intended status is proposed standard.
Hi, Lars. I don't know if this is on.
I think you need just to eat the mic.
Okay, yeah, you have to actually go right there with the mask. So not having read this in a very long time, I mean, we have this grand tradition in TCPM of publishing things on the standards track that have no implementation, but I thought we had sort of managed to get away from this a little bit. So I'm not thrilled, right? But you can make the case we've done it before many times. I'd feel better if there was one, though.
As a personal note, I think past choices should not reflect upon future ones. I think we should do the right thing, as Spencer Dawkins would say.
Gori.
So EDO is what standard status at the moment?
The intended status is proposed standard.
Yeah, and so I would expect quite a lot of people to want to use this, even if there was no implementation, because kind of like, why isn't it AXP?
Corey, I believe you said, why do the RFC if no one's going to implement it? Is that correct? Oh, sorry, I apologize. We just lost you for a bit. You kind of turned away from the mic right at the very end.
Yeah, it's a stupid mask thing. I get the protocol wrong. Yeah. So I said, I presumed quite a lot of people said they wanted to use this in some way. And if they did, then maybe PS is okay, because there's an intent to implement. But if there's no intent to implement and there's no implementations, then perhaps it's just EXP. Yep.
Thank you, Gori. That's good feedback.
This is killing me, so I'm in the queue, please. As an individual, yeah, like I don't see a reason not to do it EXP, but maybe I'll ask the broader question: why are you continuing to progress this draft if no one has any intention of implementing, much less deploying it?
I think one of the reasons, if I remember it correctly, if one of the reasons is that it not only describes the way how to extend it, but also how other solutions are and why they don't work. So it's kind of it's also kind of a documentation thing.
That's great. That's an informational RFC.
Lars Eggert, can you remind me if the code point can be assigned if it's experimental? Oh, it wants an option number, right? What I don't, I should remember this, but I don't. Is a specification required? RFC required? Standards action, or I guess any of the other options? I think it would be good to check, right? Because if we make it experimental and you can't get the code point, it's sort of
Yeah.
we have
One
experimental
exception
option range.
One exception is MPTCP.
But I think we can check on the list whether there's an intention to implement.
Yeah. All right. With that, shall we move to the first presenter?
Yep. Bob, you're up.
Sorry.
Beforehand, Michael.
I just want to make sure they're in the order.
Michael,
Sorry, yes?
somehow you are not showing in the Meet Echo. Did you log in?
Sorry, what?
Pardon?
You are not in the participants list.
Oh, that could be. Yeah. I can change that.
Oh, yes, I didn't realize that. All right. Bob, please.
Okay.
Start.
Right. This is more accurate ECN feedback in TCP, and that still looks like an old slide.
Okay. I will refresh. Hold on.
It's only.
I
it's only-
uploaded the new ones we got in the last moment. But
Okay,
I think we
yeah.
have to refresh.
all
that.
that's happened is the draft number has gone up 2
Is that still old?
instead of 1 because when I submitted it, I did it in 2 stages. So the RFC XML formatting changes wouldn't poison the diff.
Bob, do you know if this is the new one?
That looks like the old one still, but it doesn't matter. I can explain.
I can, let me just reload the whole thing. And if that fixes it, then great. And if not, then
Yeah.
I'll let you talk through.
Yeah, it should say 22, not 21. That's the only difference. And 20 to 21 was a sort of null change, and 21 to 22 was the actual change. But it's still minor anyway. Are we there?
Let's hope this one works. Oh,
Still being shared. No, never mind.
okay.
Next slide.
I'll just.
All right. So, yeah, the substantive change is actually 21 to 22, and it's not very substantive. In fact, Richard, while we were doing interrupt testing, noticed that there was nothing in the spec about what happens if multiple SINs arrive, or at least it says what happens if they arrive, but it didn't say which one you do the feedback for. It did, on the other hand, handle the case of multiple SIN ACKs, and so we just added some text saying you should feedback the latest one. If anyone wants to think about whether maybe you should feedback the most serious feedback, you could do that, but we figured it's better to feedback latest feedback rather than stale feedback. Yeah. Okay, and we recorded the ION early registrations. That's it. You can move on. The chair's asked if we would do a sort of retrospective on the whole of accurate ECN for this session, given we're about to go to working group last call, I believe. So this is a bit of a roadmap on the next few about the next few slides. The goal and the approach, the relation to other activities, where it sits in the stack, what aspects you will need to look out for when you're reviewing it, and the implementation status next. So the goal is to feedback the extent of congestion, not just its existence within a round trip, so that congestion controls that use that have the mechanism in the base feedback of TCP. It's, I guess, very similar to the concept behind SAC for drop, but translated to ECN. Yeah. The goal for doing that, the immediate goal for doing that, is to allow congestion control to achieve very low queuing delay of the order of those numbers. Next. So the problem was that RFC 3168 ECN feedback that was added to TCP back in 2001, when any number of CE marks hit the receiver, it latched up echo congestion experienced and started feeding that back for reliability, and then only stopped when the sender sent congestion window reduced back to the receiver again, which meant that if you got 1 or 10 or 300 CE marks, you got the same signal going backwards. So that was the meaning of congestion existence. So we need to move on to extent. I've put a table there of ECN stuff if you don't know it, but I hope anyone in this room will know about ECN. Okay, next. So the solution to that we adopted was to use the 2 bits that were already, or 2 flags that were already in the main TCP header for ECN, to override them once the 3-way handshake had got started, and use actually a 3rd bit that was also used historically for the ECN nonce, well, used in quotes because it wasn't clear whether it was used. So we overloaded them and made them into a 3-bit counter, and that would be essential and always used. And then there was an optional TCP option that you could also add for extra precision with 24-bit counters for the bytes. And the ACE field counted just packets, and the option we counts bytes fed back. Next.
Bob, may I ask a question as an individual? Just to clear, I'm curious, what do you think is the likely deployment ratio between the option and the core ACE functionality? I'm just like, as an individual, do you think it's going to be depending on use case, or what are your thoughts?
I think that possibly more in data centers, you might not need the option. I think you might need the option more where you've got middle boxes and stuff, potentially doing a lot of ACK coalescing and things like that. So the 3-bit field might wrap too fast. But well, you know, that's my feeling. I don't know what might happen.
Okay, well, thank you. I appreciate it.
Yeah. Okay. Next. Right. So there's quite a lot in the introduction about what the relation is to other activities. First of all, DCTCP was the, if you like, poster child of extent-based feedback. And that was where we learned that it was useful. The problem was that DCTCP didn't negotiate this new form of feedback, so you potentially had one end doing one form of feedback and the other thinking it was doing the other. That was fine in a data center that was administered by one sysadmin, and it could that sysadmin could ensure that everything was configured correctly, but on the public internet, that's a bit more problematic because there isn't one sysadmin, I believe, still. So we have added this negotiation phase during the 3-way handshake, and in fact, it will fall back to the old form if one end doesn't support the new form of ECN, and indeed, if one end doesn't support any ECN at all, it will fall back to just using drop. So both ends have to support it. In the Linux implementation, we have actually written in a way for it to use the TCP style of ECN feedback, which is different, the sort of toggling case, but that's not in the spec. right? So, but that can be used internally in data centers and privately. The next thing it relates to is other congestion controls. Now, accurate ECN is pure, the spec is purely about the feedback mechanism and the wire protocol for doing that. It steers clear of saying anything about congestion response. Well, I think it mentions the words, but you know, it doesn't say we've got to do about it. Really, feedback is architecturally below the congestion control. And so the congestion control depends on it. And that means you can use accurate ECN feedback for any congestion control algorithm. And that includes the ones that don't need the higher accuracy, you know, that only want extent and not existence, like Reno and Cubic. So the callbacks in the implementation still work just the same, whether you use old or new. So it is a replacement for the existing TCP ECN feedback, not just you don't have to choose which one you use. The other thing this relates to is the L4S experiment, which is probably the first example of something that uses it. Hopefully not the last. It is intended to be generic feedback. Obviously, both ends have to be able to use accurate ECN in order to get that accurate feedback, but only one end needs to actually be L4S capable, as far as, because L4S is a sender congestion control thing, whereas the feedback is a end-to-end agreement. And finally, it relates to another draft ECN++ that that's what the title calls it now, but the draft name is there. And that removes the rule in 3168 ECN about not using ECN on TCP control packets and retransmissions. And the accurate ECN spec recommends using ECN++. I think that's okay to do that, even though ECN++ is experimental and the accurate ECN spec is proposed standard. Yeah. Okay. And the other way around, there are also aspects in the ECN++ spec that you can't use unless you're using accurate ECN. Okay, next. So where does it fit in this stack? Just to explain the diagram, that's not an implementation diagram, that's what works over what, right? The idea is you've got IP at the bottom there, and ECN++ is really about whether you set the ECN field in the IP header, so it's really about below TCP, even though it's in TCPM. And then the TCP layer, I've split there into two sub-layers for the feedback, and then the congestion control above it. And I think I've mostly explained all this on the previous slide. You have to enable accurate ECN and it will fall back. You have to enable it on both endpoints and it will fall back otherwise. No dependency on anything in the network. And as I said, it replaces rather than and extends the 3168 TCPN feedback rather than being an alternative. And also, importantly, out of scope in the accurate ECN spec is there's nothing about what the sender puts in the ECN field at the start. It's only about the feedback of it, and there's nothing about the sender's congestion response. Next. So these are the sort of parts that really need looking at closely if you're going to review this for working group last call, or if you already have. Hopefully you've looked at these things. Negotiation phase, there's a lot of stuff in there, particularly about detecting mangling through middle boxes and such like, and backward compatibility with old schemes, forward compatibility with potential new schemes, fallback contingencies and things like that. So that's That's quite a sort of sensitive area to have a look at. Then there's resilience against ACK loss and coalescing and things like that. Please have a look at that. And implications of TCP wire protocol changes on either implications of middle boxes on that or implications of that on middle boxes, because anything you change on the wire could affect that. And then there's a section on interaction with TCP variants. So if one of those is your favorite variant, I think we've considered all the combinations, but please have a look. And finally, in the security considerations, there's all stuff about flooding attacks, feedback integrity, downgrade attacks, and things like that. So we're nearly there. The implementation, we've got 2 slides on this. We've been doing interrupt testing all this week down in the hack demo area of L4S and Accurate ECN. And the Linux implementation that ILPO primarily did, Neil has updated to be based off the 5.15 Linux kernel. And there's a pull request, I think hasn't quite happened yet, but it's still imminent to go into the L4S repo as well. Also the packet drill tests, Neil has updated. Then Richard here has been implementing it on FreeBSD. That will be in FreeBSD 14, I believe. That's great, yep. But without the optional TCP option. And Richard's done a lot of the coding around that, but still the parts of the TCP option, well, there's some heuristic stuff not to do with the TCP option left, and some details of the TCP option as well. And so far it passes all the packet drill tests that I mentioned above, that except one to do with the TCP option, obviously, because it's not implemented. Right. Okay. And moving on, second slide about implementation. Apple platforms now also implement the Accurate ECN, but only the reflector side, so that we can test it against a sender. So that means that it will not really work as a sender, but it will allow you to use Accurate ECN between the two. And it's off by default in macOS, iOS, and all the other, you know, iPad, iWatch, I think therefore I am, or whatever. The way to turn it on is written there: NetINet, TCP Accurate ECN, syscontrol. And finally, as I said, all that has been being interrupt tested fairly extensively over the last week, which is how Richard found the problem in the spec. The little thing about the multiple sins. It's also been, Richard's also patched TCP dump, but that hasn't got through yet, but it's been submitted. And the Wireshark, Michael has got that patch through, so it's now in 4.0. It will show you the correct Accurate ECN flags. I think that's getting close to it. Yep. Yeah. Okay.
So are there any questions?
Hi, Bob. Surely in your copious L4S experimentation, you have data on how often the option makes it through the internet, I assume? And if so, could you share the results?
Actually, no, because all the interrupt testing at the moment is testbed based. So we have none of that.
Oh, I see. Okay.
Yep.
So we actually did some tests. What was it? From my lab, from a FreeBSD machine in my university's lab to the internet, and figured out that the net module in FreeBSD clears the AE bit. It will be fixed, but it was one of the results. The options went through, at least on that path.
Yeah, I mean, for the AE bit, we did many years ago, actually, testing on that. But yes, we haven't done recent testing. We did a massive set of tests, or that was Marcelo Bagnolo and Anna Mandalari. And there's a paper on that that's referenced out of the draft, but the option wasn't like it is now when we did that. Yeah, and we didn't actually find that problem on your, I guess we did it on mobile networks and we did it on fixed networks, but didn't see that problem in a BSD NAT.
No, it's the NAT module from IPFW. If you use that, then
right.
It uses that bit for internal things, sets it internally, and clears it because it thought no one used it.
There's questions in the queue, Bob. So,
okay.
Oh, did I? Oh, correct. Sorry, Christian. I just removed you accidentally instead of letting you present. Could you get back in the queue? Oh, Christian, could you get back in the queue so I can allow you to present? I apologize. There you go. Why can I not grant? What is? Okay. It says remove him. Where? I completely forgot where the button is. I'm feeling very silly right now.
Christian, can you just?
I think you can just
grab the mic.
Yes. Okay. Yes. Do you hear me now?
Yes.
Yes.
Good. Yes, I have a question. In this ECN negotiation option, what happens if there is a path change during the connection? That is, suppose that you are doing ECN fine, and then the routing changes, and somehow you start going through a box that washes the ECN bits, or even worse, the ACE bits. What happens then?
Right. What washes the first? I'll deal with it, washing the IP layer. Yes, the accurate ECN negotiation checks for mangling during the handshake, but it doesn't continue to check for it. But there are statements in the spec about implementations may, I think, I can't remember exactly, you know, check that things are still continuing, but the idea being that the idea from May being that you don't really want to have everything continually checked all the time when you're in the fast path, if you like. So and you know, don't want to make people check things for years to come. I think that sort of depends on how likely it is to happen. At the moment, from our testing, any bleaching tended to be at the first hop, so it's sort of less likely that a path change will lose the first or change the first hop. But yes, it could happen. And all I can say is that accurate ECN is a lot better than ECN 3168 ECN, which did no checking at all. So it's a compromise between how often you check these things. And ultimately, if your ECN is mangled,
Okay.
if you fill up a buffer somewhere, you'll get a loss, and then you respond to that. You know, so yeah.
Just a quick clarification. When you say first hop, do you mean first hop at either end, or do you mean specifically on the sender side?
We were testing from clients, so it was the first hop from the client was right. Tending to be where any bleaching of ECN was happening.
Right. So I have a case. So when we did ECN for Quick, I found a case where it was the last hop,
right,
towards the server, that mucked with the bits.
Okay. Yeah, then a path change might if the server manages to move its state, it might. Yeah.
Richard, I think it's your turn if you'd like to contribute your thoughts.
So I just wanted to expand on the interop testing across the internet.
Close to the mic.
I just wanted to expand on the interop testing across the internet, and that was done last time between a Linux box that Neil provided in two different hyperscalers, one of which did actually the bleaching, the other one did not. And we did also do these tests with the accuracy option, basically reconfirming what we have found early on, like 8 years ago, when we did some real serious investigation about the viability of the accuracy option and the bits to traverse the internet. So no big surprises there, really.
Thank you, Richard. Corey? And Corey will be the last speaker on this because we are just about to run out of time.
Can I just say that on mangling, you know, I'm sure there will be a problem somewhere. However much you test, you won't find everything. You know, it's.
Yeah, Gary Fairhurst. I remember us going through the mangling test and how often we talk about this, and there is stuff in the draft. It's a bit complicated, the draft. But I guess the answer to Christian is please read that draft and figure out whether the text actually says it, because we need to make sure it's right.
Yeah.
But there is text in there.
Yeah.
Okay. Thank you very much, Bob.
Okay. Thank you.
Martin, you're up next.
Good afternoon. I wanted to get a sense from the group about appropriate byte counting in RFC 3465. It's been inspired by some recent events. I've worked, like many of you, I've worked on TCP for a long time. If you'd asked me a couple years ago, like what is the last word in the RFC series about ABC, I would say, oh, well, it's RFC 3465. And isn't it annoying that that's experimental? And that's actually because, you know, for document reasons. But that turns out not to be true, and I think we should take a look at it. Next slide, please. So in the beginning, this is what was in that document. There was a congestion avoidance thing and a slow start thing. And for slow start, we had this value L, which is the maximum number of MSSs you would ACK in a single ACK, or that you would accept as ACK for congestion control purposes, and that was set to no more than 2. Next slide. Now that whole congestion avoidance bit, actually, if you go look at RFC 5681, it takes that and recommends it. So that 5681 is, of course, the main standards track Reno congestion control document. So this is completely taken care of. This is now in the standards corpus. 5681 also took slow start, the slow start behavior, but limited L to 1. And so so if you were doing L equals 1, you were completely standards track. If you were doing L equals 2, you were doing an experimental thing. And if you were over 2, which by the way, the Linux kernel does by default, if I'm not mistaken, here we go again, then I guess you're off the, you know, completely out of bounds of IETF land, but you know, we know how that goes. Next slide. So what has changed recently is this high start thing, and this is what we alluded to briefly in the document review. In my opinion, in the AD review, what the document originally said was a little bit, it was trying to massage the need to refer to a experimental document and downref in a way that was a little bit elusive. And so what I pushed them to do is actually just go ahead and standardize when you are running slow start in conjunction with high start plus, that you can do ABC and there's no limit on L, which is what they actually, you know, tested in the internet. And so assuming that the working group is fine with that when we do this, not last call, but this second pass through the group, consensus call through the group, then this will move onto the standards track. And so the status will be what you see in this table here in the lower right, that, well, again, the congestion avoidance has always been standards or for a long time. If you're doing high start plus, you can sort of do essentially whatever you want with any value of L. If you are not running high start plus, then depending on your value of L, you are either in proposed standard land, you are in experimental land, or you're once again out in the wild. Is there another slide?
Yes.
Okay, so there are a few options here. One is you could just do nothing. That's always an option. Certainly, you know, there's always a case that a lot of these non-interoperable issues that don't relate to interoperability can be safely ignored. But you know, I had the misperception. I was probably not the only one, and I think it is misleading to people to point to this document. A second, intermediate difficulty option is for me to initiate a document action, which makes 3465 historic. and just say, look, as a community, our best practice, there's a thing called slow start, and it includes high start plus. And so if you're doing something other than that, you're not following the best practice anymore. And that means that some things are not unspecified, but does leave a nice tombstone in 3465 that says, by the way, this has been standardized in these following other RFCs, so you need not do this experimental thing anymore, which is achieving my objective at least. And then the last option is we think that one corner where non-high start plus with ABC L greater than 1 is important. We could do a new tiny PS to kind of sanctify that in a standard. Whether that is worth doing or not, that's kind of what I want to ask the community. I don't, Ian.
Ian Sweat, as an individual, I have a question, which is, at some point, presumably, BBR will finally be standardized, and BBR's current startup is not high start plus. It is a notably different algorithm. I've implemented both, and yeah. What will we do about that? Are we going to just throw the same text we threw into high start plus into BBR startup and just say like it's duplicated, but we don't really care? Or do we feel bad about that? And do we think that if two documents start saying the same thing over and over again, that it's duplicative? Or does BBR just reference high start plus and say, this isn't high start plus, but like, if you're doing BBR, then this also applies?
Well, first of all, I think we're fairly far from BBR being standards track. Sure. But when
nonetheless, yeah, fair point.
But when that time comes, my understanding of BBR is it will be like pretty new, like this whole like congestion avoidance slow start model is really creaking and maybe breaking, and you really ought to write down what you're doing, like when you receive an ACK, which presumably will have some ABC elements in it. So you can have a separate standards track document that is like writing down what you were doing, and if that makes it through the process, it makes it through the process. You don't need to rely on these other documents to do that.
Michael, would you like to go next?
Michael Tixon from the floor, not being able to get into that queue. A similar point is Ian brought up with what to do in BBR. What if in the future high start plus has people are using different things? So I would prepare some future-proof solution which is not tied to using a particular algorithm we are having now on the table, more or less by accident. I mean, it's the document we have right now, so we want to shift something in, but there is no guarantee that in 2 years nothing else comes up or so.
So is the group's consensus that high start is not actually necessarily best practice, but kind of maybe an optional thing that you can do?
No, it's right now. But what if in 2 years? Or I mean, BBR uses something else. So
again, I think if we specify a new slow start-ish thing, that is going to be standards track, then there's no like document down ref issue. It will just specify what the new behavior is. If you mess with slow start, you mess with slow start, and you have other things. It doesn't. I think new standards, new crash control standards are neither here nor there in this discussion.
I didn't get the last sentence.
So I think it's just an orthogonal. I don't think that the state of new slow start-ish proposals in the standards track is affected by this one or the other, because they will simply specify what to do, which may or may not include appropriate byte counting. And there's no need to reference 3465 or high start plus or any of the other documents. They're just going to state what they do, and if they have consensus, they become a standard.
Okay, and they specify whatever they want.
Yes.
If they want to change. Okay.
Now, if someone has a congestion control and they want to refer to 5681 slow start, like without really specifying it, then they're stuck with 5681 slow start. But I mean, it's just a paragraph to add to the document saying, oh, but you can also do this other thing.
Lars,
yeah, Lars Eggert. So I think I'm going slightly in the same direction as Michael, but maybe sort of from the top rather than the bottom. So there's another option here, and that is like open up 5681 and do a bigger lift and a more principled, discussion of this whole space. It's a big lift. So where's Wes Eddy, who has free time now to write a document for us? But it'll be not quite as heavy as the 793 BIS, but it will be significant, right? And the question is worth it, but I think it's an option, and it would solve some of these things, right?
Yes, that is a even. Yeah, that's cranking this scale of work up to 11. If somebody has it into them, right, a 5681 BIS 00, I think everyone would welcome that. There's always some tweaks to be done. But unless somebody stands up, I don't know that that's good. Like, I mean, I could write out any of these without, in a day and start the process. 5681 BIS is a much bigger project. Christian?
Yeah, as we go. Yeah.
Queue closed. Yeah.
What's it when you're standing up?
Christian, can't hear you if you're trying to talk.
Christian? I'm going to let Gory go first in the sake of time, but we'll come back to you, Christian, if you can get your audio working.
Yeah, Gory Fairhurst at the mic. And Christian here. Christian, go ahead.
Yes, I'm sorry. I mean, I'm too old. I forgot to unmute. I'm sorry. I mean, at some point in a few years, my brain will turn into mush, and you won't have that problem because the situation will be clear. But in between, I am with Lars and Michael on this discussion. I think it's a mistake for the IETF to specify implementations in that case rather than specify rules and desires. I mean, for example, clearly the rule for slow start is that you shall not create big overflow and end up with a lot of losses, because that's bad. Okay. And it's clear that high start does that. It's not the only way to do that. I mean, Ian pointed the different solution BBR. There is also a lot of research on chirping, which will make a quick assessment of the bandwidth, and it's particularly useful for long delay links. And so I think it would be much better to have principles rather than reference to specific solutions, if we are to make some kind of best practice.
Are you volunteering
the solution as a reference, saying, hey, yeah, not alone.
So I mean, I guess
not by myself. By myself, as I said, yeah.
So Lars proposed option 4, so maybe option 3.5 is just to rev slow start specifically, and along the lines of maybe something that Christian outlined, and that's certainly fine. I don't have the bandwidth to do that personally, whereas these other things I do have the bandwidth to do, so I think that's a concern as well. Unless someone is volunteering today or soon. Gory.
Hey, Gory Fairhurst, I don't normally do this. I don't like option 2, and I might prefer option 1 of your list at this moment. We were just in a side meeting talking about satellite systems, but I suspect other systems also are playing around with high start plus, and the algorithm's an algorithm, it interacts. Maybe we will come up with something slightly different in the short term. Maybe we'll be wiser and know what the actual recommendation is. So I just wonder whether we're just kind of a little bit ahead. We know we need to do something, but I'm not sure we know exactly what we should write at this moment.
Okay.
Thank you, Gory.
Hello. I would like to propose it might be a simple way out of this, which is in fact option 3, but using a should. I mean, the point is that whether we have high start or not, whatever mechanism we have, it's probably never going to be a fantastic idea to have a huge burst or a set of huge bursts, right? And we could include the number 2 in the should instead of the number 1. That probably won't make the world melt, but it is a principled thing to avoid having bursts. And if you have good reasons against that, and it could be text explaining, right? Mm-hmm. that algorithms in the style of Heistad could be a reason against that decision. So you wouldn't, but make it a should.
So what is in HiStart++ is may choose any value for L, should choose infinity if you have pacing, and without pacing, and if you pick whatever number if you are smart enough to do it. If you don't know, just pick 8. That's what's in that document right now.
I think it specifies, it focuses on 8. It's not any number, it's 8 has a special position there.
Yes, it is should choose 8 unless you understand what you were doing. Like people have disagreed about this, but I think it is important to give the naive implementer some number to grab as a magic number, rather than just say, no, just go find a PhD to tell you what your L should be. Other people could disagree about that. We can have that comment on the list, that discussion on the list, but and we'll have an opportunity in review for the HiStart document.
Yeah.
So are we done?
Thank you. Yeah, we're out of time. Thank you very much, Martin Duke.
Thanks. Well, actually, I'm sorry. So that was not the incredible encouragement I had hoped to find. So I think, I mean, we should probably conclude with an action item. And I guess the option is to do nothing at this time, but to like be more annoying about asking for somebody to draft this new standards track document.
Do people want to poll? Show of hands. Okay. Okay. Sorry. Make sure I pick this up. And oh, that's the question. Oh, sorry. Are there not 3-way polls?
No.
Now I have to do like a game theory tree. Okay. What do you think you would like?
So the consensus from the floor was let's do a PS document. Okay. So maybe like that's the question: should we do a PS document? And then if we want to have a show of hands on who's willing to help co-author that, that would be amazing. But we can do that, see how that goes.
Okay. I have opened the poll. Would you like to do a PS document?
Would you like there to be one? Is the first question, right?
What?
Is it? Would you like there to be one, or would you like to do it?
Oh, sorry. Okay. Please answer that as though, like, would you like the working group to do?
Would you like there to be a new PS document that you're not necessarily committing to write? That is the question.
I apologize. I can't edit it after. I don't want to create 3 polls and have them all thrown away. So it's all right. I'll give folks like 20 more seconds because I do want to keep things moving, but. I'm not seeing any new votes, so I'm gonna end the session. There we go. And we have 9 people. 9 people raised their hand. 3 people did not raise their hand, with a total of 12 people. It's quite a few fewer than is in this room, let alone this session. I'm not sure if that's an indication of lack of interest or what, but that's the information we have.
Okay, so chairs, do you think we have a? Well, actually, can anyone who says we should not do that like stand up and like object or like propose a different course of action? Because no one spoke up for 2, option 2.
So, Lars, I think there's sort of no sense of urgency, which is sort of what I think is motivating a lot of the passiveness, right? It's just not. That's my read.
All right, that's reasonable.
Go for it, Christian. Oh. You've been led in the queue, so if you'd like to speak.
It seems to take a long time for him to start up his session.
Okay, Christian, I think we're going to move on just in the sake of time. Mary, did you?
Yeah, he said in the chat that his connection got interrupted earlier, and like maybe the question he's in the chat is the one he wants to say. Should this be in Congress?
Oh, well, it could be. Yeah, I'm assuming that working group stands up. That would be a great place for it. Although probably like the people who would write it are in this room anyway, I would guess. But all right, so I guess sort of, I mean, you guys can judge the consensus. It's not my role in this case, but I think we're going to have to punt this to without a proper decision.
The chairs can discuss it on the side, and then we'll decide like what to do next.
Yeah. So I guess I will not move forward with doing anything myself, and we will have to discuss this more. Thank you.
We need to move on. TCP ACK request. And if you can be quick, it's appreciated.
Okay, hello everyone. My name is Carlos Gomez, and I'm going to present the last update of the draft entitled TCP ACK option, our option. Next, please.
You also may take off your mask if you want to, if it's easier
No,
for you.
it's fine.
Okay.
As long as people hear me.
Okay. Yeah, I just want to make sure you do.
Okay. So first of all, a review of the motivation for the draft. Delayed ACKs is a widely used mechanism which is intended to reduce protocol overhead. However, in some cases, it may also contribute to suboptimal performance. For example, there are so-called large congestion window scenarios, meaning a congestion window size much greater than the MSS, where saving up to one of every two ACKs may be insufficient. For example, when there may be performance limitations due to highly asymmetric path capacity, or when we may want to further reduce the computational cost and network load of too many ACKs. There is also so-called small congestion window scenarios where the congestion window size would be up to the order of around 1 MSS, such as in data centers where the bandwidth delay product may be up to the order of 1 MSS. In that case, delayed ACKs will incur a delay much greater than the RTT, and also in transactional data exchanges, or when the congestion window decreases, the ability of requesting immediate ACKs may help avoid idle times or allow a faster congestion window growth. Next, please. So on the status of the draft, perhaps you may recall that there was, before the creation of this document, there was some prior discussion in the area of center control of TCP ACKs, which appeared to converge to defining a new TCP option serving two purposes, providing a sender with the ability of requesting a given ACK rate or requesting immediate ACKs while keeping the steady state ACK rate. So today I'm presenting the updates in version 06, which aims to address the comments from the last meeting. Next, please. So let's go through the updates. The first one is in the main format of the option, the one that conveys the requested ACK rate value. So after comments in the last meeting, we are going back from a size of 6 bytes to 5 bytes because there were comments that there's this lack of space for TCP options, especially in SYN packets. So now with the current format, the R field, which is the one that carries the binary encoding of the ACK rate, would be of 7 bits. The maximum value that could be encoded here is 127, and we still have one reserved bit, which might be useful for future users, for perhaps future encodings or values of R if needed. Next, please. The other main update in this last version is the addition of Appendix A, after a comment by Bob, because he mentioned that perhaps STAR was converging somehow to something similar to RFC 5690, which is also known as ACK-CC. So we tried to clarify, to provide some comparison here, to clarify the potential similarities and differences between the two documents. So first, about the main goals and features. ACK-CC is an informational RFC. To our best knowledge, it has not been implemented. The goal in this document is reducing ACK traffic when there is congestion on the reverse path. So the idea is to apply congestion control on ACKs. And it is somehow a relatively complex mechanism which has different components, a component to detect lost and ECN marked pure ACKs, a mechanism for calculating the ACK ratio, a mechanism to announce ACC support by means of a new TCP option, and a method to indicate new ACK ratio that's indicated by means of a second new TCP option. Regarding TAR, the intended status is experimental, and the focus is a bit different. It's rather on end-to-end performance and also end system resource conservation. The idea is that TAR allows the sender to request a given ACK ratio from the receiver, an immediate ACK while keeping the steady-state ACK ratio, and TAR appears to be a quite simple tool, which perhaps could be a component of other more complex mechanisms, including but not limited to mechanism for ACK congestion control, but also including the different benefits in different scenarios that I mentioned at the beginning of the presentation. Next, please. So regarding how the new TCP options would be defined in these two documents, regarding ACC, it defines two TCP options, one intended to announce ACC support, which is always present in SYN packets, another one intended to communicate the ACK ratio, and as far as I know, there is no TCP option kind value assigned by IANA for this. And about TAR, which is has been defined more recently, and also it has the experimental intended status. It uses a single TCP experimental option kind value, so it follows RFC 6994. So this single option kind value is used to announce support of TAR and also to request the ACK rate. By the way, announcing the support of TAR may be done in SYN packets, but it doesn't have to be. Okay, and then there is one experimental ID value, which is 00AC, which has been allocated by IANA. Next, please. So, wondering about next steps and considering the current state of the document, the authors feel that the document is somehow getting stable. The purpose and methods should hopefully be clear. There is even some initial code of a prototype implementation started by Michael, led by Michael for FreeBSD. So we would like to ask the working group whether the document is perhaps ready for working group adoption.
Any comments, questions?
I just started the poll per your request. And so now I'll give you 1 minute to answer if you would like to adopt this draft into the working group.
You want to say something? Yeah. Just go to the mic. Can you eat the mic, please? I mean, not really, but.
Can you explain a little bit why you need that? So because you say data center delayed ACK inefficient, but application or TCP implementation just put push flag, right? So it can kind of explicitly ask for immediate ACK, right? So can you explain a bit about what the exact problem in data center applications?
Yes.
Caused by delayed ACKs?
There is one DNS related document which is referenced in the draft, which describes this sort of issue where you may send a packet, then you will have a delay until you get the response, which is just introduced by.
So the client sends some data and then server waits for next packet.
So I think the interaction, the issue there, it's RFC 8000 something. It's about DNS. So there was some interaction where an endpoint was sending a packet, and then the response was delayed just because of the presence of the delayed ACKs.
So why does the sender just put push flag on that?
Sorry?
The push flag. Usually TCP receiver, when it receives a
the
packet,
the push flag.
Push flag, then they immediately returns ACK.
This was discussed in initial presentations of this effort, and it seemed like it was not exactly that we could actually use push for this.
Why?
I mean, the answer was still delayed, I think.
Why?
I don't remember all the details, but I...
May I ask that, just in the interest of time, this might be a good side conversation since this has been discussed in the past, but I'd like Michael to talk.
Yeah, so the point is that on the receiver side, it's not specified that you send an egg immediately when you receive a push flag. Some implementations do, but you can't rely on that. BSD, for example, does not.
So what is the reason why the receiver does not respond immediately in case of receiving push flagged packets?
I'm going to argue that's out of scope for this draft because that's an implementation choice of existing.
If there's no good reason not to implement that immediate act for push flag, then that everyone just should do that, isn't it? Instead of defining new TCP options.
Just a very brief answer, that is not the purpose of the push flag. It has a different purpose.
Gory, technically you're next on the queue. Sorry, Mira.
So, Gory, I'm just a little bit concerned that perhaps there are other things in the network doing 3449 and other ACK mangling, and we have offload. Like with Quick, we understand the stack probably. With TCP, I'm less sure. So is there information about how the network responds when you kind of do this and what result you get when you try and do something at the receiver and the network's also doing something?
Sorry, could you repeat the last? Yeah.
You can put it in notes. I'll send an email and we can discuss. So I'm looking for information about the combination of what the network does in RSC 3449 and offload, and what this mechanism will do when you combine them.
Okay.
I'm looking for data.
And please discuss that on the list.
Yeah.
So I would like to keep using the mic queue, at least as we're not saying our names on the mic. That would be helpful to keep the mic queue for everybody. But I'm here to relay Christian. That's why I ended the queue. He said in the chat, if we do something for controlling egg rate in TCP, should we try to keep common concept with the delayed egg option in Quick? This would be this would help building common experience.
Okay.
Yeah,
thank you, Christian. Thank you for relaying, Mira.
So we got the result and make a decision based on also further email feedback.
Thanks. I'm going to move on to the next. Oh, and start. Oh, that's actually what's on the slide. It's like there's a big X button on my slide. It must not work.
I think it was 21 in favor, 21 raised the hand, 3 did not. So we had 24 people giving an opinion.
Please go.
Hi everyone, I'm Wei Wang from China Telecom, and I will give the presentation of this draft on behalf of the co-authors. Next slide, please. Next slide, please. First of all, I will introduce the background and motivation of this draft. With the rapidly increasing of the customer number and the service requirements, we need a more flexible and scalable network, and the increasing of the edge resource pools make the service node that provides the same service functions can be deployed in different resource pools and use the same Anycast IP address. And as the scenario shown in the figure, the R1 is the ingress router, and R2, R3, and R4 are egress routers. Each egress router connects to a service node, and the 3 service nodes provide the same service function. And when the customer A accesses to the service, it will send a packet to R1, and R1 will determine the optimal service nodes for the customer A based on the network status. And since the since the network status is constantly changing, so different customers may be scheduled to different service nodes. But for the customers who have established the connections, the service node that provides the service must remain unchanged. And next slide, please.
Lars, do you have a question? Oh.
Yes. To keep the established connections unchanged, the current solutions need to maintain the customer-based connections data tables in ingress and egress routers. This is a lack of flexibility and scalability. We proposed a solution for the service affinity between client and server based on one newly defined TCP options. And these options can realize the comprehensive scheduling based on real-time network status. This solution can eliminate the need to maintain such tables in the network devices and can improve the flexibility and scalability of large-scale deployment of Anycast services scheduling. Next slide, please. We think we also need a new flag. We called it ICF flags to identify the sender can support the TCP service affinity options. When the customer A accesses to the service, it will send a TCP packet in which the SYN and SAF flags are set, and the destination address of this packet is set to the Anycast IP address of the service. And when R1 receives the packet, it will schedule the request and determines that service node behind R4 will provide the service, and it will forwarding this TCP packet to R4 to the service node through R4, and the service node will return its IP address and port information through the service affinity options to the customer A. And finally, customer A will establish the connection to service node behind R4. Next slide, please. This is the encoding of the newly defined TCP option. And this option can identify the IPv4 or IPv6 address and port information owned by the service node, which provides the service. And this option is carried in the TCP-FN packet sending by the service node. After receiving the TCP-FN packet, if the newly defined option is included, the customer will establish the connection to the address specified in this option. And next slide, please. Yes, since this is the first time for us to give the presentation of this draft, and any comments or suggestions are welcome, and we will update it accordingly. Thank you.
Lars?
Hi, Lars Eckert. Thanks for the presentation. That was very clear. I really feel this is the wrong level to solve that problem at, because you're basically asking all TCP client stacks to change so that the server side can optimize some load balancing, right? So you have the problem, it's never really going to happen to all clients. So you need to continuously be able to handle the case that some clients won't do this. It also introduces sort of the other way to say this is, why wouldn't you do this rather at the application layer, where you can basically deploy this? You can deploy this with TLS, because this information wouldn't be secure. It can be changed in the network. So you can imagine an attacker might want to rewrite those things and have the clients go over there, or just like route them somewhere where there's no response. So that there's a whole bunch of things here, I think, that come together that make me sort of think that you probably want to solve this at a higher layer rather than at the TCP level. Thank you.
Thank you. We do this load balancing on the transmit layer is because we think the application layer have difficult in obtain the network data in real time, and so we think we can push this function in the transmission layer.
Did you want to address that question?
Yeah.
Okay.
So I'm a Quadra and make some explain. You know, there are two ways. Currently, there are two ways to explore accomplish such aim. The first is the application layer only. So, but for application layer, as Mr. Ms. has said, the client or the server cannot know the network status. So we think, and the network cannot do any help for the optimization of the traffic. So I think our solution is aligned with the coming concept for the computing and network convergence trend. So you know, the network can get the service status and can optimize the traffic by the for the client traffic. So, but we cannot depend solely on the network to do such thing, because to keep the service affinity, the network device must store much status table on the device. So our solution is one hybrid solution. And we depend partly for the network device to select the optimal application server, and we depend on the client and the server to do something for the service affinity. This is our aim. Okay.
Bob, please be quick.
Yeah. Hi. I would before Lars said what he said. I hadn't thought of that, and I tend to agree with him. But just I'll say what I was going to say anyway, because haven't completely thought about all this, and that was that it might be better to first of all hash this information and just have like a cookie in this option, so you're not, you know, and then that reminds me of something that I was involved in doing earlier, which is a SYN cookie, but it allows you to have more information in the SYN cookie than currently possible in that space. So it's a very similar thing that gives you effectively a bit of connection state, soft state, moving with the packets. So there may be other things you could sort of fold into it to make it more useful, so that clients do use it, which might mitigate some of the reasons Lars said it wouldn't happen.
Thank you.
Ian Sweat, as an individual, I agree with Lars that I think this is probably the wrong layer to put it at, but I think regardless, I think there are some potentially serious privacy concerns about the way you structure this. And I think an opaque field along the lines of what the quick LB draft proposes is more aligned with like the current values of the IETF. So something like an opaque SYN cookie would at least be a preferable option. I don't think I want to design this right now, but I think for the IETF to adopt this, I suspect it would have to be substantially changed in order to kind of conform to the standard privacy policies of like what we see today.
Thank you. Please continue the discussion on the list. We are running out of time here. Thank you.
Thank you.
Yashi, you have the remaining 6 minutes instead of 15. Sorry about that.
let me quickly. Can I share my slide? Okay. Okay. So I just would like to talk about analysis for the difference between standard condition control schemes. Moving on to the next slide. Okay, so what's in this draft? So basically, this draft provide a list for the difference between three congestion control standards. First one is Rhino, and the next one is Quick Rhino, and the last one is Cubic. And then I have basically three motivation to write this kind of draft. And first one is during the cubic discussions, we have a lot of productive, nice comments for the cubic fairness. So having this kind of document may be a good record for that very productive discussions. Oh, please go back to the previous slide. Then another motivation for me is it can be as a useful reference for the future discussion with the congestion control principles. So right now there are some difference between these three standards, but it might be better that these three standards have the same congestion control principles. And if we move to that direction, this kind of document may be a good starting point for the discussion. And then third motivation for me is, having this kind of document may encourage further analysis because some difference in the draft may require some more large-scale experiment or something like that. And then what is out of focus for this draft is the evaluation for the differences. So there are some differences, but this draft does not give this difference is big or small, something like that. The purpose of this document is to provide the list. That's it. Because as I said, it may take time to evaluate these differences. Okay, please move on to the next slide. And then I just would like to quickly overview of the difference between the drafts. And I would like to start from Rhino and the Quick Rhino. There are several parameter differences, like initial window is different, and loss window is different, and then loss detection scheme is a little different. And then they might think it might be there are minor difference, but it affects performance. So you might need to sort it out to some extent. Moving on to the next slide, please. Okay, and then also the slow start threshold after packet loss is different. In 9002, slow start threshold after packet loss is the half value of congestion window when packet loss is detected. But on the other hand, 5681 says it is the half value of flight side instead of congestion window. And then also, RxC 5681 basically prohibit to use congestion window here because it says an easy mistake to make is to simply use congestion window rather than flight side. So to some extent, these two documents seems to be contradict each other. Please move on to the next slide. And so another difference between Rhino and Quick Rhino is window growth in slow start. This may be overlap that Martin talks. In 9002, congestion window can be increased by the number of acknowledged byte in AXA packet. But in case of 5681, there are limit. So it can increase at most one segment by a single ACK. And that's the difference. Okay, now I'm moving on to the, okay, let's go to the, now I'm moving on to the next one. The loss recovery algorithm is different. So definition of the loss recovery algorithm is different. In 9002, it can exit recovery period when one of any packet sent during the recovery period is acknowledgement. In 5681, it can end recovery period, all lost segment found before recovery period acknowledgement. So in case of 9002, if just one retransmission packet has been sent and ACKed, then it can end the recovery, although there is another lost packet. On the other hand, 5681, if we have 4 lost packets, then all packet has been retransmitted and should be ACKed. Otherwise, it cannot end the recovery period. That's the difference between the Reno and the quick Reno. Okay, moving on to the next slide, please. And then there are some difference between Reno and the cubic draft. The big difference is multiplicative Windows decrease factor. 5681 use 0.5, 83 12-bit draft is 0.7. 0.7 might not be too aggressive, but might not be very fair with 5681. Okay, moving on to the next one. And then another difference is Reno-friendly model. And as we have a long discussion, there are some, skepticism about the validity of this model. So this is also the discussion point. Moving on to the next slide, please. So this is my last slide. So discussion point of this draft is these differences accessible or needed to be sorted out. If it's needed to be sorted out, how do we proceed? Do we want to update 5681 or do we have another way to do it? And the final discussion point is it worthwhile publishing this document as a reference or not? That's feedback I would like to get from the community. That's about it.
We're out of time, so I will let Martin Duke and Lars go, and then we'll wrap this up.
Okay. Yeah. Yoshi and I obviously didn't coordinate. So like as for the 5681 versus 9002 stuff, I would say that 9002 probably reflects, I mean, aside from very quick specific things, is mostly kind of the best current practice that we'd probably agree on. And that rather than do something like this, I mean, you've created a checklist for 5681 BIS, so let's do 5681 BIS rather than have an intermediate document. For the cubic stuff, I don't know. Thanks.
Yeah, just Lars, thanks for doing the legwork. This is a nice summary of all the differences. So thanks for doing that. For 9002 specifically, I think we actually discussed all of those sort of we deliberated them, and they all deliberated changes, and they all were last called. And so there's a difference, and we can sort of decide what we want to do here. I would sort of argue that 9002 is the newer document and therefore more accurately reflects current thinking, but it's a discussion for another day. But thanks, this is an excellent starting point for future work.
As an individual, I'd add one comment that the congestion control working group, if it was created, might be the right place to ensure consistency going forward. And with that, this is the end of the TCPM session. Thank you for being patient and going 3 minutes over.
Can I make one last comment?
Sorry.
Yoshi, go ahead.
Okay, sorry, just make quick. So about 9002, so I'm okay with using choice of this parameter for 9002, but to be fair with TCP and Quick, I think then if Quick use this parameter, then one argument is TCP might be used the same parameter.
Thank you.
Yeah, exactly. So 5681 BIS should be probably more like 9002. Yes.
Okay. Thank you, Yoshi. Bye.
Thank you.